MATLAB is a very powerful environment to do a lot of calculations in. It also has the makings of a lot of programming languages. It has a lot of features that can make people write pretty advanced scripts, essentially their own programming language. And so one aspect of programming languages is modularity in writing a function. So today we're going to learn how to write a function in MATLAB and Octave. MATLAB and Octave are just different in one line. There's one little line that's different between MATLAB and Octave, and so I'll make sure that I outline that when it comes along. Okay, so we're going to do linear regression in a modular way, and I'm going to start as my template. I'm going to use linreg1. So I go into File Manager, I look at the linreg1 folder in my Octave folder, and then I'm going to make a copy of that. I'm going to call it linreg2. Okay, so then I go into that, I change the name of it to linreg2, then I go into that folder and I see linreg1.m. I'm going to change that to linreg2.m. I also want to make another copy. So I'm going to make a copy of that linreg2 and then just call it linreg.m. See, I told you a couple videos ago that I wanted to, or last video that I wanted to save for linreg. So linreg is going to be the function. In MATLAB and Octave, functions have their own M files. They're not part of the main program. They're totally separate. So you have to keep all function files. They need to be named what the name of the function is, and they need to be their own separate file. This is a detail about MATLAB and Octave. Okay, good. So then I go into Octave, and I get to the right folder. I get to linreg2 folder by using the browse button up there. You can, and I go to the right folder and I click choose. In Octave, in MATLAB, you just click on the thing and you can get to the right folder with the bar there. It's that easy. Good. Okay, so now I'm in the right folder and I have the two files, linreg2 and linreg1. I want to edit both of them. So edit linreg2.m, edit linreg.m, and both of them come up. They're the same. They're the exact same file. And what main thing I'm going to do is erase stuff from each of them, right? So let's start with linreg2. In linreg2, I'm going to erase all the calculations for MB and R2. Just erase them. Then I'm going to replace them with a function call. And the function call is going to like this. In square brackets, M, comma, B, comma, R2 equals linreg, open parentheses, X, comma, Y, semicolon. This is interesting. First off, with the input argument list, like most functions, is in parentheses there on the right-hand side of the equal sign. So the new function I've made is linreg. That's the second file that we're actually going to make that function. Good. And then so X and Y are the input. Look at the outputs. You can have 3 outputs. As long as they're in square brackets and they're separated by commas, you can have as many outputs as you want to a function. This is better than a traditional programming language like C, where in order to get multiple outputs out of a function, you have to kind of finagle it with pointers and all that stuff. You don't have to do that here. You can have one function that calculates the linear regression and gives you all 3 values, slope, intercept, and R squared. Very cool. Good. So that's the only thing you have to do with linreg2. So I've changed that line, save it. I'm done with that. Now in linreg1, I'm going to have to turn that into a function. So what I do with linreg1 is I erase all the other stuff. I erase all the plotting, all the loading of data. I erase all that stuff. I just have the equations there. Good, starting with some x. To make a function in Octave and MATLAB, the first line of the file has to be function space, then the way that you call the function. So square brackets M, comma, B, comma, R2 equals linreg xy. It has to be that way. The name of the function linreg has to be equal to the same thing as the name as the M file, linreg.m. That's how I saved linreg, right? Because linreg makes more sense as a function name, right? Okay, below that I put some percents, right? In that is where the help is going to go. So you can create your own help when you say help and then help space linreg, whatever you print in those green things. I'm not going to do it for this video, but whatever you want to show up for those for the help command goes in right underneath the function call in MATLAB or Octave. Okay, so so then I have all the calculations, that's it. And then for Octave, at the bottom, you need to say end function, all one word, end function. This is the one difference between MATLAB and Octave. MATLAB don't do that. No end function from MATLAB, it just ends. The M file ends and it knows that's the end of the function. For Octave, you need to put end function or you'll get an error. That's one, so we've come across, just besides the graphical interface difference, this turns out to be the only significant difference between Octave and MATLAB that we've encountered so far. Everything else has been point by point, character by character equivalent. Okay? All right, so that's just one little detail. If you're using Octave, not MATLAB, make sure that you'll put end function down at the bottom of that function. Save that. Then when I go back into the command window and I just type linreg2, remember linreg2 is going to call linreg, right? It's calling the function, so you never have to call linreg. Linreg2 is doing that in the script. So linreg2 is the main script. It's the equivalent of main in C or a main program in a traditional programming language, right? So I just type out linreg2, enter, and it pauses. It shows me the raw data. I press spacebar, then it shows me the actual final graph with the points and the linear regression on it, and it spits out the MB and R2 values. That's it. So that's how you make a function in MATLAB and Octave. The first line of the code says function space, how you call the function. The name of the function has to be equal to the name of the M file, and that's how you make a function work in MATLAB.